So with our analysis plan in place, I went ahead and executed that, and I'm going to show you the results of the analysis. First of all, click on the Dataset tab, and you can see that this is the subset of data that I'm going to be using, that I've removed the questions that I don't want to include in the scope, as well as all questions before fall of 2014. So then my analysis. So the first thing I did was to define the null hypothesis. So for this analysis, I'm stating the null hypothesis is that there is no difference in response distribution between online and on-campus students. So that means that I'm really not seeing a statistically significant difference between how online students answered or responded to the survey questions versus the on-campus students. And then that means the alternate hypothesis is that there is a difference in response distribution between the online students and on-campus students. So that means that there is a statistically significant difference between how on-campus students responded to the survey questions compared to online students. So that's the target, that's the analysis that I'm going to be doing. So I'm executing a chi-squared. So as I mentioned in the planning, my analysis planning, is that I was not happy with how Excel reported the chi-squared result in terms of probability. I wanted to see the actual value so I can show more transparency. So what I did is I set this spreadsheet up to manually calculate the chi-squared. So I have a summary table for each of the survey questions. So this number that you see right here represents the survey question number. And then I counted from my data subset of the number of students that responded either strongly disagree, or neutral, or strongly agree or agree, and counted each of those up for the on-campus, for the online students and the main campus students, and then totaled them up for everybody that disagreed, everybody that was neutral, everybody that was agreed, the total of the online students that responded, and the total of the main campus students responded, and then the total responses overall. So that's the summary table that I created for all the responses for question 34. Now, those were the observed results. So then what I needed to do was calculate the expected results. So this would look at the percentage of students that were online students. So if I take the 144 and divide that by 2188, that will give me the percent of respondents that were online respondents. So if I want to look at my expected, I'm going to say that I'm going to see an even distribution based off of the percent of students that are online students. So out of 120 students, if I say that I'm going to look at the distribution of that 120 results to see which percent of those would be online students, I would find that 79 of those 120 respondents would be online students. So the calculation is carried out by taking from my observed values, the total number of online students divided by the total of students, taking that result and multiplying it times the total of students that responded strongly disagree or disagree. And then that result gets placed right here. And then I carry out that same calculation for all responses for online and main campus students. And that would be my expected results. So now I have a summary table of observed results and expected results. So using those two summary tables, I'm able to then manually calculate the chi-squared statistic, and I place my value there. And then I repeat this for each of the 16 questions where I calculate the chi-squared based off of the observed and expected values. Next, I'm going to take those values and now evaluate them and put them in my summary table. So over on the left side, for each of the 16 questions, I placed my chi-squared result. And then what I did is I looked up the threshold for a chi-squared result based off of a degrees of freedom of 2. So but using that evaluation, I see that any chi-squared value that's greater than 5.99 is statistically significant at the 95% confidence interval. So that each one of these values, which happen to be over 5.99, are statistically significant. That means each of my questions that there is a statistical significance in the difference between how our online students responded to that question and compared to how our on-campus students responded to that question. So next what I did is I formatted the result to a format that we would use if we were going to be publishing the results. So the format looks like this, and unfortunately I wasn't able to do an exponential notation here, but that's what this x would look like. So the chi-squared with 2 degrees of freedom and a sample size of 2,188 had a result of 21.13, which is obviously greater than 5.99. Therefore, the results that the probability of this being due to randomness is less than 0.05. So that means at the 95% confidence level, this result is statistically significant. So I also then formatted the results for all the other 15 questions in the same format to show my chi-squared results. But the key point here is all of them are statistically significant. Next, what I did is I looked to compare the percent of online students that responded either disagree, neutral, or agree to each of these questions. And from that percent, I subtracted the percent of main campus students that responded disagree, neutral, or agree. And what I found out here is there is differences. So for question 34, there was a 0.6 percent difference between the students that are online versus face-to-face. Question 37, actually less online students responded negatively than on-campus students. And then I did the same thing for neutral and agree. Next, what I did is I took a look at the mean response. So, this is supposed to be a categorical data. The Likert scale is really categorical, but if I were to look at this from a numeric perspective and take the mean of all the results, I see that online students for question 34 had a mean response of 4.408, and the main campus students had a mean of 4.252, and then the difference is slightly in favor of the online students. So then I calculated that for each of the 16 questions. So then taking a step back and looking at the results, I came up with a set of observations right down here. So my first observation was that for all questions within the scope of the study, so all 16 questions, there was a significant relationship between the campus and the course eval responses. So that means that there is a difference and that difference is significant between the responses of our on-campus students and our online students. Number 2, with exception to question 119, online students responded favorably at a higher rate than on-campus students. And question 3, observation number 3 is noting that questions 51 and 54 resulted in the greatest difference between online and on-campus students' responses. And then observation 4, for all questions within the scope of the study, on-campus students were much more likely to respond with a neutral response compared to online students. Online students, therefore, must be responding more agree or disagree and with a lesser extent of a neutral response. So these are the results of the analysis. That we still need to put this in context, but the analysis is providing the data that we can use to then provide context, which will then connect us back to our research questions and the problem that we're trying to solve. So this is my analysis on the course eval survey data, and the results were conclusive. With a chi-squared that is greater than the threshold, therefore the 95% confidence level, I've demonstrated for each of these 16 questions that the null hypothesis is not valid and that the alternate hypothesis is true, that there is a difference in response distribution between online and on-campus students. My alternate hypothesis is true for all 16 questions.